Okay, let's kick things off. We are diving deep into, well, the architecture of apparel today. And I want to start with a statistic that honestly is pretty baffling for anyone in product development.
Mm.
It seems most fashion designers, they only use about, 23% of the available seam types in their collections?
Just 23%.
And here's the real kicker. Over 40% of the seam options that exist are basically unknown or just never used.
Yeah, completely off the radar for many.
When you think about that, the vast majority of garments relying on just a handful of the same structures, well, you immediately see the limitations there.
Oh, absolutely.
That leads to repetitive design, sometimes functional weak points, and honestly, a huge amount of missed innovation potential.
It really is the difference, isn't it, between just sort of knowing how to sew two pieces of fabric together
Right.
and actually mastering the engineering that lets that garment perform properly. So our mission today really is to move past those basic, maybe repetitive details and get straight to the foundation, understanding seam classification.
Yeah.
Because this knowledge, it's absolutely foundational. Choosing the wrong type of seam, it directly impacts a garment's durability, its functionality,
Yeah.
and fundamentally its longevity and how it looks, its aesthetic appeal. So if you really want to enhance both the look and the quality, understanding classification is that first crucial step. It moves you into, well, a higher tier of design thinking.
Okay, let's unpack that because there's definitely an information overload potential here. Our sources mentioned seams can be categorized by, loads of factors: stitch type, cost, application, you name it. It gets confusing fast.
I really can.
But for professional product developers, maybe we just need to focus. Our sources point to two major classification systems used in the apparel industry.
That's exactly right. And it helps to think of them as maybe two different languages you need to understand, especially when communicating. The first system, this one is really centered on the designer's intent. It's classification by purpose or function.
Purpose.
Yeah. This method organizes seams based on their main job in the finished product. Is it for construction, finishing, or is it decorative? It basically answers the question, why is this seam here?
Got it. Why it's there. And the second system sounds more like the nuts and bolts, the one that speaks to the factory floor.
That's a good way to put it. That's the classification by construction method. These are often referenced by ISO or ASTM. This system answers, how is this seam physically put together? How is it sewn?
Okay, so the designer might choose the purpose, let's say a decorative one.
Right.
And then the manufacturer executes it using a specific construction method, like maybe a lab seam. That distinction, purpose versus construction, feels really, really key then.
It is.
Okay, so let's follow the source materials lead here and zero in on classification by purpose, focusing on those three functional categories you mentioned: construction, finish, and decorative.
Great. Let's start with construction seams. Now, instead of just calling them heavy lifters, let's think more about their mechanical role. Their core job is obviously joining fabric pieces, but crucially, they also have to manage the mechanical forces that result. We're talking tensile stress, shear stress.
Right, the pulling and stretching.
Exactly, especially in high-wear areas like armholes, crotches, side seams.
So they aren't just joining, they're structurally determining how the product resists stress and keeps its shape when worn under load.
Precisely. Their key benefit is distributing and managing that stress. That ensures the foundational integrity, the strength of the whole product. So if you're using, say, knits, a construction seam might need a specific stitch, like an overlock, to allow for stretch without breaking.
Makes sense.
But if you're working with wovens, you might opt for a really robust seam for maximum strength, less give needed there.
Okay, that clarifies construction seams. Moving on then, we have finish seams. If construction is about bearing the load, finish seams sound like they're more about preservation.
Preservation is a great word for it. Preservation and often elegance. Finish seams are designed very specifically to secure those raw fabric edges. Their primary goal is stopping fraying and unraveling.
Which can wreck a garment over time.
Absolutely. That fraying can lead to catastrophic failure down the line.
Totally agree. Okay, and finally, the category that seems to offer designers the most creative freedom: decorative seams.
Decorative seams are fascinating because they are, well, the most versatile in many ways. They definitely serve ornamental roles, enhancing the design's look, but they often mask an underlying functional role too.
Wait, okay, let me jump in there. If a decorative seam, like, say, some visible top stitching or maybe a complex pin tuck, is actually used to modify the garment's volume or create structure, isn't it functionally acting as a construction seam at that point?
That's a great question.
How do we draw that line, especially in something like a tech pack?
Yeah, that brings up a really important point about hierarchy, about primary function. In the tech pack, you always prioritize the primary role. So if that seam is fundamentally holding two pieces together in a high tension area, it's a construction seam first and foremost. Even if you choose a decorative stitch type, maybe like a chain stitch, to execute it for visual reasons.
Okay, primary function wins.
Right. However, if the seam's main purpose is only to create an aesthetic detail, like a very precise tuck or maybe a corded design feature that doesn't actually bear any structural weight, then its decorative purpose takes precedence in the classification.
Got it.
The key benefit of decorative seams, then, is that they let you create really unique aesthetics, modify volume in interesting ways, and introduce structured design elements without necessarily being about load bearing.
Now we absolutely have to ask the so what question. Why should a designer or anyone in product development really master this beyond just, avoiding getting stuck in that 23% rut we talked about?
Right. Well, mastering this knowledge translates directly into, I'd say, 4 massive professional benefits. These improve collection quality, your efficiency, and yeah, ultimately your bottom line.
Okay, let's hear them.
The first major payoff is precision in design execution. Simple as that. When designers truly understand the functional implications, not just the look, but what the seam does, they choose the most suitable options right away. Knowing the difference upfront ensures accuracy, it saves huge amounts of time during sampling, and it prevents those really costly mistakes that force big redesigns later in the process.
Yeah. Saving time and money, always critical. Okay, moving into the practical side of things. Benefit number 2 sounds like it's all about communication.
Benefit number 2 is efficient communication with manufacturers. This is huge. Your tech packs, they're essentially the contract between you and your factory. And clear seam knowledge is absolutely non-negotiable in that contract.
Right.
If you just specify, say, French seam, but the factory uses a slightly different seam construction, maybe in a type that doesn't meet your requirements, well, you've just introduced a potential error.
Through lack of specificity.
Exactly. But when a designer can reference the correct construction type, it streamlines production instantly. Everyone's speaking the same technical language. It minimizes guesswork. It minimizes those subjective errors.
And that ties directly into the bottom line, which brings us to benefit number 3, cost-effective decision-making. I'm guessing this involves not over-engineering things sometimes.
Absolutely. It's all about balance. You have to balance quality with cost efficiency. Understanding how the seam's purpose translates into material needs, thread consumption, and the sewing methods, the labor time involved, allows for really informed choices. Let's take a simple hemline. That's a finished seam, right? Now, if you specify a really complex, maybe 3-row cover stitch, you are significantly increasing thread usage and the labor cost per garment.
Okay.
If that garment doesn't actually need that level of super flat finish or extreme durability at the hem, maybe a simpler, clean edge finish seam would provide perfectly adequate longevity. But maybe for 30% less cost in materials and labor, it's about smart choices.
Yeah.
You don't over-engineer a simple finish, but you also don't under-engineer a critical construction point. That's sophisticated cost management right there.
It makes perfect sense. And the 4th benefit sounds like it speaks more to maybe confidence and innovation, that feeling of creative liberation.
That's exactly it. The final benefit is empowerment in design decisions. When you truly master these classifications, you gain confidence. You're no longer just defaulting to that small 23% of seams you already know.
Yeah, the safe ones.
The safe ones. Maybe because you're worried the factory won't understand your tech pack if you try something different. Instead, designers can move beyond just aesthetic intuition. They can choose seams based on actual performance requirements, material compatibility, is it woven versus knit, heavy versus light, and the real functional demands of the garment. And that confidence, it results in well-executed collections that really stand out in the marketplace because they perform just as well as they look.
Okay, so tying this all together, what does this mean for you, the listener, the learner? Really understanding the difference between a construction, a finish, and a decorative seam, and crucially, how those purposes get executed using those technical construction types. That's the foundation. It feels like it's the permission slip you need to innovate, because now you actually understand the mechanical boundaries you're working within. You know the rules before you try to bend them.
Well said. And just to recap the most crucial point from this deep dive, seam classification, particularly thinking about it by purpose, dictates durability, function, material usage, and the ultimate design outcome. Mastering this intersection, where purpose meets construction, that really is the key to elevating your product from just being assembled to being expertly engineered.
Right. So if mastering seam classification is genuinely the key to ensuring accuracy, saving that precious time, and preventing those really costly late-stage production mistakes, we want to leave you with this final, maybe provocative thought and mull over. Considering that statistic that maybe 40% of seam options are currently unknown or unused by most designers, how many potential design breakthroughs, whether in functionality or drape or even significant cost savings, are currently being missed? Missed simply because we tend to default to the easiest, most common seam type in our collections.
Makes you think, doesn't it?
It really does. Maybe it's time for everyone to consciously expand that functional toolkit.